The star Betelgeuse, often confused with a character from the film, is indeed a colossal celestial body. If we were to exchange its mass with that of the Sun, it would extend beyond the orbit of Mars, potentially reaching the asteroid belt. Even more concerning is a recent alarming discovery made by the James Webb Space Telescope regarding Betelgeuse. Astrophysicist Neil deGrasse Tyson has shared insights on this topic. Despite being located approximately 700 light-years away, Betelgeuse is the closest star to our solar system that scientists predict will eventually end its life in a supernova explosion. Tyson has frequently commented on Betelgeuse, noting its remarkable size and striking red-orange hue, which make it one of the most visible stars in the night sky. He emphasizes that it is the nearest star likely to undergo a supernova blast. Like all stars, Betelgeuse will eventually exhaust its core fuel, leading it to expand significantly, potentially engulfing the orbits of Mercury and Venus, and coming dangerously close to Earth. Imagine witnessing a sunrise where half the sky is illuminated by Betelgeuse. Betelgeuse is also known for its variability, with its brightness fluctuating over time. At its peak, it can shine so brightly that it rivals the most brilliant stars in the sky, reaching a magnitude close to 0. There have been theories suggesting a possible supernova event for Betelgeuse, which could be a frightening sight for observers on Earth. However, this possibility might not come to fruition. It's crucial to understand that a star's brightness can vary significantly. When comparing Betelgeuse with other stars like Rigel and Antares, it highlights this variability. While these stars can appear similarly bright, they can also change drastically in their luminosity. Despite the ongoing discussions about a potential supernova, researchers are keen on monitoring Betelgeuse's behavior to better comprehend its fluctuations and identify any significant changes that could signal an imminent supernova event. The speculation surrounding Betelgeuse's potential explosion has garnered attention due to its size and prominence in the night sky. However, astronomers and astrophysicists remind us that predicting such cosmic events is complex. Although Betelgeuse's recent dimming has attracted interest, it is essential to remember that stars, including Betelgeuse, undergo natural cycles of variability. Researchers continue to observe and analyze Betelgeuse using various astronomical instruments, including the James Webb Space Telescope. This advanced telescope has enhanced our ability to study distant stars and galaxies, providing valuable data that aids in understanding stellar behavior and potential changes. The process of a star reaching the end of its life and culminating in a supernova is a complex astronomical event. While Betelgeuse has piqued interest and raised questions about a potential supernova, mainstream scientists approach such possibilities with caution. Learning more about the life cycle of stars, their behaviors, and the ultimate fate of these massive celestial entities is a significant opportunity for discovery. The changes in Betelgeuse's brightness arise from various factors, including its size, temperature, and distance from Earth. This variation in luminosity is a natural result of the star's cycles and characteristics. Over the past 5 years, Betelgeuse has experienced substantial changes, presenting unique challenges and stimulating scientific curiosity about these variations. Aside from Betelgeuse, this distinctive star is known by alternative names such as Alpha Orionis and Al Mankab, showcasing the diversity in naming conventions across cultures. It is fascinating how a single celestial body can have multiple names and spellings, each rooted in historical and linguistic contexts. The origin of the name Betelgeuse can be traced back to Arabic. Researchers frequently debate the most appropriate spelling and pronunciation for this name, with Betelgeuse often considered more fitting. Located in the Orion constellation, Betelgeuse shines as a red supergiant star, captivating observers from its position approximately 642.5 light-years away from Earth. Its considerable distance contributes to its status as one of the most extensively studied and mesmerizing celestial objects visible in the night sky. The information we have about Betelgeuse's distance comes from various sources, including the Hipparcos astrometric satellite. This advanced instrument has provided critical insights into the vast distances separating celestial bodies. However, differing data sources sometimes yield discrepancies. For example, while the Hipparcos satellite estimates Betelgeuse's distance at about 430 light-years, Other measurements suggest a distance closer to 642.5 light-years. These inconsistencies highlight the complexities and challenges of accurately measuring cosmic distances, emphasizing the ongoing refinement and advancement in astronomical techniques. Understanding the vastness of our universe involves grappling with the immense distances between celestial objects. Betelgeuse, with its intriguing variability and colossal size, presents an exciting case for astrophysicists and astronomers. Its distinctive characteristics and observable behavior significantly contribute to our understanding of stellar evolution and the broader universe. The fluctuations in Betelgeuse's brightness over the mentioned period have prompted further inquiries and observations. The unique nature of this red supergiant offers an extraordinary opportunity to comprehend the life cycles of such massive stars and the intricacies of their behavior. Astrophysicists and astronomers have employed various tools and methods to closely monitor Betelgeuse, seeking to decipher the underlying causes of its variability and any potential implications for its future evolution. This period of change has sparked heightened interest in the star, leading to extensive research and discussions within the scientific community. While there have been speculations about a possible supernova event, the recent dimming and subsequent brightening of Betelgeuse raise more questions than conclusions. It is essential to exercise caution when making predictions, as the natural variations in a star's brightness are part of its inherent nature and do not necessarily indicate an impending dramatic event like a supernova. Understanding celestial bodies involves considering various factors, including size, temperature, distance, and their intrinsic properties. Betelgeuse remains a significant astronomical object, offering invaluable insights into the behavior and life cycle of massive stars. Ongoing observations and advancements in technology will continue to enhance our understanding of these fascinating celestial entities. Recent research continues to unveil insights into the intriguing concept of Betelgeuse, also known as Alpha Orionis. This star stands out as one of the most prominent and fascinating members of the Orion constellation, characterized by its significant variability in brightness, ranging from apparent magnitudes of 0 to 6, classifying it as a variable star. While Betelgeuse holds the designation of Alpha Orionis, it often appears brighter than it truly is due to its unpredictable nature. The designations Alpha and Beta Orionis were assigned to Betelgeuse and Rigel, respectively, by Johann Bayer in his work Uranometria, published in 1603. This classification aids astronomers in distinguishing and identifying stars within the Orion constellation. Unlike many other stars, Betelgeuse exists as a solitary star and is not part of a larger cosmic group, residing in a region devoid of star formation activity. Its classification as a red supergiant further sets it apart, reflecting its trajectory and distance traveled through space. This colossal celestial body has a radius approximately 1,000 times that of the Sun and a mass roughly 20 times greater than our solar star, boasting a luminosity equivalent to about 126,000 suns. Despite its considerable distance of about 548 light-years from Earth, Betelgeuse remains a fascinating subject of study. Its surface temperature, around 3,600 Kelvin, is notably cooler than the Sun's 5,778 Kelvin, contributing to its distinct red supergiant appearance and playing a critical role in its brightness and observable characteristics. At around 10 million years old, Betelgeuse is relatively young in cosmic terms compared to our Sun, which is approximately 4.6 billion years old. Despite its youth, Betelgeuse has undergone significant stellar evolution, reaching a stage where it exhibits the characteristics of a mature red supergiant. Given its immense size and current evolutionary phase, theories about Betelgeuse potentially undergoing a supernova event have emerged. If such an event were to occur within a few hundred light-years from Earth, it would undoubtedly have profound implications for our planet. While scientists emphasize caution in predicting such galactic phenomena, the possibility of a supernova from Betelgeuse garners attention due to the potential consequences for Earth. Understanding the life cycle and behaviors of stars like Betelgeuse enhances astronomers' comprehension of cosmic evolution. Ongoing observations and studies of this red supergiant continue to deepen our knowledge of stellar evolution, providing insights into the fate of massive stars and the spectacular cosmic events that shape our universe. Supernova explosions mark the catastrophic endpoints of massive stars' lives, releasing immense amounts of energy that can outshine entire galaxies. If a nearby star, such as Alpha Centauri, were to undergo such a violent event, it would undoubtedly capture our attention, flooding our environment with intense radiation across various wavelengths. The sheer scale of such an event could make its brightness comparable to that of the Moon, but its effects could be far more significant and potentially hazardous for Earth. In our solar system, no supernova has been observed since 1964. However, in 1987, a supernova erupted in the Large Magellanic Cloud, a neighboring galaxy about 169,000 light-years away. Known as Supernova 1987A, this event showcased its effects even at such a great distance, making it a notable cosmic occurrence in recent history. The remnants of supernovae, such as G292 plus 1.8, provide insights into the aftermath of massive stars' deaths. Each supernova remnant has unique compositions and characteristics, with G292 plus 1.8 being particularly rich in oxygen. Fortunately, the vast distances separating these cosmic events from our solar system mitigate any potential risks associated with such monumental occurrences. The concept of a danger zone surrounding a typical supernova is an intriguing topic of discussion. This hypothetical area, estimated to extend about 100 light-years, represents the potential impact zone where a supernova's effects could significantly influence nearby celestial bodies. However, this assessment remains debated, as the actual range of influence from a supernova is a subject of ongoing research and discussion. In relation to neighboring stars, Alpha Centauri is within a plausible range that could pose a significant risk if it were to undergo a supernova. In contrast, Betelgeuse, despite its immense size and intriguing behavior, is situated at a distance where its potential supernova event may not have an immediate impact on our solar system. Current data and conditions suggest a prevailing sense of safety regarding an imminent supernova threat. Nonetheless, ongoing studies of celestial phenomena and stellar behaviors remain crucial for enhancing our understanding of potential galactic risks and their implications for Earth and the broader universe. The investigation of vast events like supernovae continues to drive scientific inquiry, enriching our understanding of possible threats within the universe. Despite the attention surrounding Betelgeuse's potential for a supernova, it has not occurred. Instead, the star has been exhibiting a pattern of dimming and brightening, indicating that it may simply be undergoing a phase. While Betelgeuse could eventually explode, it does not appear likely to happen in the near future. Betelgeuse's location in the Orion constellation, marking the right shoulder of the Hunter, makes it a prominent and easily recognizable feature in the night sky. Its distinctive ruby hue enhances its visibility and allure, making it an ideal target for astronomers and stargazers alike, especially in the early months of each year. To unravel the mystery of Betelgeuse's behavior, researchers have extensively analyzed data from various sources, including NASA's Hubble Space Telescope and other observatories. These observations have provided valuable insights into the star's recent activity, suggesting that Betelgeuse underwent a significant surface mass ejection in 2009, resulting in the loss of a considerable portion of its apparent surface. This behavior is unique and remarkable in the context of stellar observation, as such phenomena have never before been recorded in a star of Betelgeuse's size and prominence.